Evenings are the beautifully sweet spot between the harsh light of the day and the dead darkness of night. Good evening to one and all present here. On behalf of PG and Research Department of Mathematics, DG Vaishnav College, Chennai, I welcome all the PG students and CSIR aspirants. Prayer is simply talking to God like a friend and should be the easiest thing we do each day. Now, Tamital Vatu followed by college prayer.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழி எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் மிகுந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Once again, I welcome everyone to our 12th C4 session. I'm very glad to invite our resource person, Dr. K.A. Venkatesh, Adjunct Professor, IIIT Bangalore, Professor of Mathematics and Computer Science, Myanmar Institute of Information Technology, Myanmar. I welcome you, sir. Now, I hand over the session to you, sir.
So there was a cap for this session due to festivals and other things. I hope everyone enjoyed this session as well as the festival. In between, there are some natural disaster. That is a challenge for us. We have to win amongst any kinds of odd comes in our way. We know how to overcome. So this is part and parcel of our life. So anytime anything can happen, how we can improve for tomorrow's time. That is what the idea. That's the reason we are also going ahead with this program. Having said this, The previous session I talked about transportation problem. Then I used LPP to solve transportation problem. So why LPP? Because it's easy to solve. There is no need of going for two-stage approach, finding the initial basic feasible solution, then go for optimal solution using Modi method or stepping stone method, modified distribution method. The Modi method is called as modified distribution method. So that we stop that. And if you have gone through any book or any material on that, there's a very elementary level only. It is not easy. No mathematics is required. Just a fun. You can play around with that. Especially northwest corner rule. Identify the northwest. It is going to be topmost on the left hand side. Allocate. How to allocate? There is something called as supply and demand. Between these two, identify the minimum one, then choose that cell, allocate whichever is the minimum between these two. So that is the way we go further. Then optimal solution we can find out. In between certain things we have to talk about. I'll talk that. Then I'll go to the other models. Okay. Anyone can recollect how we did this part, under what this models comes into? Yes, of course, it's operational research. I'm sharing the screen now. Okay. Are you able to see this one? Yeah. Now I'll put the full screen. Yes. Hope you are able to see the full screen. Yes. So this we supposed to start this part. So before that, under what chapter or what way I introduced transportation problem? I talked about transportation problem as in a particular area called as network models. So on the network models, why I'm saying this part is very important. You should understand what is the underlying principle. So instead of looking at transportation problem to solve certain things, yes, it is required. So it is basically one of the network problems. So there are certain network problems which I'm not going to speak. I said one of the popular problem, and even today it is a open problem to many researchers and people are working on, called as TSP. TSP also network problem only. So graph theory point of view, it is equivalent to find Hamiltonian circuit in the given graph. So there are a variety of TSPs are available. So that is one. Anyone can think it of TSP. Why I said TSP? A little more I'll talk about TSP. So now for you, you can view TSP how I can create as an LPP. You know, it is in the minimum time or minimum distance one has to spend to cover all the vertices in a given network exactly once and come back to the starting vertex. So this is Hamiltonian circuit only. So how to find out that, how to create LPP for this? That is a take home for you. So you can look at any problem, how you think it of, some objectives there, what are the constraints are there, identify, model it. That is one side. So network problems, one such as TSP, the other one is minimal spanning tree. As I said, Dijkstra's algorithm that talks about single source and shortest path between one vertex to all other vertices in the given network. That is another part. Then also we talked about something called as PERT and CPM, that is critical path method. When a system, a lot of activities, a project supposed to be constructed, then we have to create a network. First activity is the first activity. What is that? And all those things are possible. So this also can be extended to a software development also, where you start that we call it as multi-stage graph in the mathematical way, or in algorithmic way. You look at that multi-stage graph. There is a nice development called as dynamic programming method. So that is Bellman-Ford. They developed something called as Bellman algorithms, dynamic programming. For that, what is required is a recurrence equation, how to solve a recurrence equation. The moment I talk about recurrence equation, you should know what is a recurrence equation. If I want to say what is today's date, if you say today's date in terms of recurrence, yesterday's date plus 1, that is a recurrence. So in other words, expressing the current one in terms of the previous one. It could be multiplication, or it could be addition, subtraction with scalar. Whatever you take in a form, you can define it. That is the basic. So you should be familiarized with recurrence equation. The recurrence equation, one is I can use linear algebra way to solve it, or I can use generating functions and solve that recurrence equation also. So that is the other side. So now here LPP is known to us. What is an LPP? Single objective function with set of constraints and non-negative restriction. That is a part. Suppose multiple multi-objectives are then we call it as goal programming. The constraints and all those things are non-linear. Then we say non-linear programming, how to solve it. That is a different story. So we have all those things. So this is, as I said, assignment problem, the last class itself, it is not necessarily you'll be having a square matrix as the textbook says. It is the example also quoted. Suppose there are n jobs, number of contractors may be more than n, then how to do that? So a lot of conditions we have to put that. Okay, first we'll go with the textbook approach, then we'll say what is a practical way we can look at that. The assignment problem is very important. This can be solved again using some other method called as branch and bound technique. So many ways to solve a problem. One is, it is a special case of transportation problem. When you look at transportation problem, our objective is minimize the transportation cost from the goods to be transported from the set of nodes to set of nodes. Where we are taking the goods, that is called as pure supply nodes. Where we are going to supply, that is called as pure demand nodes. So how to do this part? So we cannot just, we are producing it, we cannot supply everything to retail stores. There should be some demand, and suppose demand is more, we cannot supply whatever amount, it is not possible because production capabilities or the capacity what you can hold in the warehouse. So therefore the constraint comes into that place as supply and demand. So the moment you talk about assignment problem, it is the simplest way. If you look at that, what are the constraints you are going to get? So before you say it's a special case of transportation problem, your question is supposed to be, what is their supply and this? So that is what important. The supply and demand here, it is going to be unit only. What do you mean by that unit? That is a constraint. We are saying that one job supposed to be allotted to only one person, and the other way, if you look at that, every person must get one job. Therefore, you are saying n by n. Finally, we are going to allot that way. Therefore, it is n by n. Now, if as a company I'm visiting your campus for a placement, what I'll do, I'll say n jobs are there. Kindly quote your expected salary for. You are capable because you are homogeneous group. Everyone is MSc mathematics. I know what is your caliber, what I'm expecting. So everybody is capable of doing all the jobs. If I ask you to quote some cost to the company or the salary, expected salary, you'll give. As a company person, what is my job? I have to give you all n jobs are available. You are also n people are available. Then we can talk about how to minimize my cost. So you may be having maximize, you put some salary, that is irrespective of others quoted. I've got a nice matrix, how to solve that. So the objective still it is minimize only. So maximize already I said how to solve maximize problem, that can be solved that way also, that is possible. So now it is a special case, that's what the third point I mentioned over here. Assignment problem is a special case of transportation problem in which all supplies and demands are equal to 1. So it can be solved with the help of linear programming. Okay, linear programming is possible, we can solve that. I'm not interested of solving using linear program, already you know what it is. If you're not familiar with, end of the session we'll solve that part also using Excel, or it takes a little more time because of number of constraints, number of variables. If you consider it, how many iterations you have to do it, that using simplex method. So that is the part. So this is the way you will have. This is very similar to what we had in the transportation problem, except left hand side, right hand side, supply and demand are missing. So C11 are the first person to do the first job. So in other words, today this is working in the call center very nicely. How many telephones are there? The telephone agents are available. How they receive the calls. So that is also can be modeled as a assignment problem. So you can think it of how to minimize the agent's cost. You can think it of all those things. Here also you can put restricted models. One agent cannot talk more than 3 minutes. How to design it. So once you have an idea, then you can design it, model it. Once you model even one problem of your own, there is no need of looking back this kind of slides of the course. You can solve your own way. So that's an idea. So in mathematics, most of the problems you can, once you know this one, can I do LPP? Can I do optimization model? You think it of, you'll get most of the problems can be solved. Then you can use tools to solve that. So underlying mathematics is required. Knowing it is also important, right? So now this is the LPP formulation. As I said, double summation sigma Cij Xij. Constraints are going to be with respect to row wise as column wise. Therefore, sigma Ji, Js 1 for each agent, that is for each task. We are here. See, previously, what is the non-restrictive restriction we had? We had a non-restrictive restriction Xij can be greater than or equal to 0. Here in this model, either it can take 0 or 1. So this is another interesting thing. So this is, we call it as an integer linear programming problem. And moreover, this integer is only 2 values. Therefore, it is called as 0, 1 LPP. So that is what we are talking about. The modification of the right hand side of the constraint set made workers able to work more than one job. That is depending on the condition that I'm not going to talk about that, because in mathematics course we are not going to study. So obviously it is not, it's a special case. So this is number of task agents, the number of tasks exceeding number of agents. So whenever it is there, as we do in the transportation problem, when you go for dummy variables, dummy column, dummy rows, the same way we can use this also to solve this one. But this we never do in the classroom environment. We'll do in terms of one particular algorithm called as Hungarian method. So that also I'll be talking about. So this is okay. This is not required. Okay. This is a problem. Just to look at that. A contractor pays subcontracts for a fixed fees plus mileage for work performed. On a given, contractor is faced with 3 electrical jobs associated with the various projects given below the distance between subcontracts and the projects ABC. So here not taken a square because I was talking about square. We are tuned to that square matrix to avoid that. So it is not a square one. So how many are there? See that 1, 2, 3, 4. So it is going to be 4 by 3. So I obviously need one more dummy. So the dummy, what I do is, because the objective is minimized, I'll add 0 as unit cost. Then I can solve using Hungarian method or LPP. So any method. So Hungarian method, what we do? That is what important. In the LPP, while talking, I talked about something called as opportunity cost. So how to identify opportunity cost? So what we do is, we call it as mathematically row reduced form, column reduced form. Identify the smallest element in the row wise, subtract it from all the elements in that row, repeat for all the rows the same operation, we'll get a row reduced matrix. What is the objective of row reduced matrix? Every row must have at least 1 0. Once you have that, then we do the same operation for column also. Look at the column wise, which is the minimal value, subtract it from every element. So every column also will have 0. First is row reduction, the second is column reduction. When you do that way, every row and every column is having at least 1 0. So then 1 0 is there. Then what you have to do? Every row, every column has, that is a place you stop reduction matrix, that is using opportunity cost. So once you do that part, you have to draw vertical and horizontal lines so that all zeros are covered under the drawn lines. Suppose I have 4 rows, every row has 1 0. Can I draw 4 lines? You look that way, but one adjective is quoted over there called as minimum number of lines. Suppose my method, my problem, all the elements in the row, every row has 1 0, everything happens to be in the first column. The moment it is in the first column, what happens? You see that I can cover with only 1 line, so not 4 lines. So you should be very careful when you are drawing the lines. You should talk about minimum number of lines to cover the zeros. Once you do that way, then if the number of lines, drawn lines equal to order of the matrix, optimality is obtained. How to go for optimality? If not in the sense number of drawn lines is less than the number of order of the matrix, then what you do? Now there are lines are there. Among the uncovered elements, choose the smallest one, subtract it from the uncovered element, add it at the intersection where the line intersecting each other, add it, then repeat this process. So you will see that after certain stage or the next stage, you will get optimal solution. Then how to choose the final answer? Look at every row wise or column wise where it has single zero. Choose that one. If it is single zero in a row, in that column maybe other zeros, strike it off. We cannot allot because every work is supposed to be given to one person and one person should get one. So do it. You'll see that all the 4 or 3, whatever it is given, the order of the matrix, you'll get everybody got one job. Then add up. That is going to be the minimal cost. This is what optimal solution for assignment problem using Hungarian method. Now you can think it of, so okay, in the transportation problem, when I am using northwest corner rule or least cost method or Vogel's approximation, initially I'll get only initial feasible solution. That is also, there is a small hiccup is there. If the number of occupied cell is m plus n minus 1, then IBFS is obtained. So there could be a chance I may not get m plus n minus 1 cells are occupied, then we call it as degeneracy. Now here the question is, have you come across degeneracy in assignment, or the Hungarian method is developed so that no degeneracy is happening, no initial basic visualization, directly optimal? Yes, it is directly optimal. There is no degeneracy will happen in this case. So you should think it of whatever you do when you say special case, you are not solving those using those methods. Therefore, here it is a possibility. Now you may ask, since it's a special case, can I use northwest corner rule, Vogel's approximation, then Modi method? Yes, you can verify it, both Hungarian method, and this is going to converge to the same solution after identifying the optimal solution. That is what one has to look into it, not solving a problem. Whenever anything is called a special case, then you should think it of, can I apply the methods to solve used in the general case to the special case? Works? Fine. If not, what is the specialty over here? Or if I do, am I doing some relaxation? That is also very important. What do you mean by relaxation? In the sense, either reducing the constraints or relaxing some parameters. Here I said 0,1 is the value x I can take. I'm saying any value for me is okay. No non-negative, only positive values or 0. I can allow fraction. Is it allowed? So that is a question mark you're supposed to have. When you do Hungarian method, instead of Hungarian method, use northwest or Modi and stepping stone. Observe that what changes. Then you will understand the concept well. Why Hungarian method is used in the books and other places. So there is a mathematical result stating that why it is better instead of using those things. Okay. So you can look at that. I'll explain with respect to this problem how we are going to solve that also. So this is the problem given to us. So there are 4. So we need one more. So one more to add that we are going to use a dummy person. Then we can put that also. So now there's a LP formulation. So as I said, that is not today's idea. But however, you can think it of agents less than or equal to 1. The task is 1. So xi 0. So Hungarian method, whatever I said, it is there. So Hungarian method solves minimization asset problem with m workers and m jobs. Because of this, always we looked at square matrices. So the special cases, we'll talk about this. So creating an opportunity loss matrix, subtracting each max, how to solve maximum maximization problem in the assignment case. So as I said, the first step is used for each row, subtract the minimum number in that row from all the members in that row. Row reduction, column reduction. So draw minimum number of lines to cover 0. If it is equal to order of the matrix, stop the process. If not, from the uncovered element, choose the smallest element. Do this part, repeat it. You will get online. So one line remain the same. So go to step 3 till you get step 3. Number of lines equal to number of order of the matrix. Till then we have to proceed. So that is this. When it comes over there, I'll talk about this part, how to allot. As I said, look for every row and column wise, any single row is there, choose that. In that row or column, any other row present, cross it, so that then you can see that one row, every row or column will have 1 and 1 0. Then choose it, go to the original matrix, choose the corresponding elements, sum up, you'll get the final answer. So this is what we had. Now we introduced one more column, dummy column with 0, 0. Now what is the minimal value? 25, 25. Yes, this side is 14, 0. This is column wise. If you look at the row wise, what is the minimal? You are going to get 0, 0. Therefore, I'm not going to talk about row wise. So only column wise will do it, because already every row got 1, 0. Therefore, no need of step 1. Only we have to start with step 2. Column reduction, we have to do that. So once you do column reduction, 25, 25, 14, then dummy is 0. So when you subtract it, you'll get this matrix. So now when so every row and every column got at least 1, 0. How many lines are required? If you look at that, only we require 2 lines. 1 line this side, so 1 line this side, right? 1 line, 2 lines. But the order of the matrix is 4. We are not reached the optimality. Then what you have to do, among the uncovered elements, which is not under the line, which is the minimal element, 2 is the minimal element, subtracted from all the uncovered elements, add at the intersection. Only one place is intersection, this place only we are going to add. Therefore, we'll get this part will become 2, this will be reduced. Then see that, all right? So as I said, 2 is the smallest element. So now we have this one. Now when you take subtracted, this is going to become 0. So therefore it increases. So now we have minimum number subtracted from this gives this one place also becomes 0. Now how many lines are required? So I can cover this way. This is definitely required 1. Then this 0 is uncovered, either vertical or horizontal line. I can draw it so that 1, 2, 3 lines, 1 line increased. So still it is number of drawn lines is not equal to number of order of the matrix. Again, we are repeat this process. 1 happens to be the smallest element. Subtract it from that. Wherever intersection is there, do it. So that is what we are doing it. 1 is the smallest element. So when you subtract it from all the elements of uncovered elements, this places 2 interaction. These 2 places will become 1 and 3. So this will become 0. So 1 and 3, this becomes 0. Once it becomes 0, now can you cover all the zeros with 3 lines? So this is 1 line, because I can draw a horizontal line. So this will become 0, 0, 0. This will become 1 line. Then this will become, because 2 zeros are covered, then I cannot cover this. This is not covered. I cannot cover these 2 zeros by single line, vertical and horizontal line. Therefore, we reached optimality. Number of drawn lines equal to order of the matrix. We reached optimality. So then, how to choose the 0? As I said, single rows and other things, you find out it. Suppose if I go back to the slide, what other things will happen here? This is going to become as, so single 0 in row or column. When I do that way, this I'll select first one, because this is going to give us only in this column I have single 0. Then correspondingly that row, this 0 I should not select and this I should not select. When I cross out, what happens here? Automatically this is crossed out, this becomes single 0, this becomes single 0, here this is there. So when I chose this one, then what will happen here? So this is first as I selected this one, then I have to this crossing out, this 2 are not there, then this is also single 0, therefore it crossed out. So I'll get this 0 and this 0. That is going to say west side is going to C, then this is going to be A, this is going to given to dummy, and this is going to give us B. So therefore the original matrix, go to the cost, you will get the cost. So now we have Hungarian method also solved. Total is going to be this. So it is given distance, you can think it of it as a cost, whatever it is, this is. So those who are in from the graph theory, if you've seen that, there is a nice theorem called as Hall's theorem. Just look at Hall's theorem, what it does. This can I apply Hall's theorem over here? So look at both, then come out. Hall's theorem is very important. Today, the distributed computing, cloud computing, the base is Hall's theorem. With that, only a lot of things are there. There are modified versions are there. Those who are into research or planning to do research, look at the application side also. You know why this we are talking about this also. The Hall's theorem, the other name it is called as stable marriage theorem. So you can go and search on that. You'll get the variety of this. Interestingly, you should know all such things so that you won't forget how to solve this kind of problems also. That is the important of this. So now, as usual, go to this website. You have to answer this question. So then we can talk about something else also. There are quite a few questions you have today, because transportation assignment only, not beyond that, anything else. So are you able to answering the questions? Now go to pollev.com, Venkatesh KA647. Then you'll see that you have to have type A, B. Okay, there is C is not there, D is okay, only A, B. It's my mistake. It is not deleted. Okay, only A or B. The objective of the transportation cost is scheduled shipment from source to destination so that the total production and transportation costs are minimized. Obviously, the general objective is that only. Therefore, it is 100%. Somebody answered it. Okay, so this is the way one can understand. If this question need not be asked in CSIR to test your understanding. This question helps us. Somebody put both. Okay, the correct answer is first one. That is true. Okay, the next question is, you have the next question is, in a transportation problem, single source may supply something to all destination. Second question, what is that problem? Because we said there could be M source and M destination, the M can be 1 also. So again, it's a bipartite graph concept. So you might have come across called as star graph, K1, N. What do you mean that middle vertex? That vertex you can view as the source. All other places can supply. Yes, answer is yes. The first one is the right one, true. The next is a transportation model have same number of rows as columns. Is it true? Is it M equal to N? No, because we know that it is M by N cost matrix, so obviously it is not. So this is the reverse way is supposed to be you have to answer. Now that's going on. Answer is false. So number of rows need not be equal to number of columns. Okay. In a transportation problem, we must always make the total supply equal to total demand. Is it true? What is we studied? When a transportation problem is said to be balanced one, in the sense then total supply is supposed to be equal to total demand. Whenever it is not equal, we introduced a dummy row or a dummy column so that the transportation problem become balanced one. So the moment it become balanced one, then only our methods are applicable. So therefore, this is true in the transportation problem. Always total supply is supposed to be equal to total demand. If it is not there, there is no need of solving. We know that we cannot supply, we lose the goodwill, the business model fails. So obviously, this condition should be met. So it is one of the 4 prerequisites to have a good model. So obviously, the first one is correct. The next question is, it's usually possible to find an optimal solution for a transportation problem that is degenerate. What do you mean by degenerate? When you are using the initial basic feasible method, either it's a Vogel's approximation method or least cost method or northwest corner rule. What do you mean by that? When you stop the first part we stop M plus N minus 1, number of rows plus number of columns minus 1 is allocated, values are gone. So that is what we call it as basic cells. Then the allotted cells or a basic cells are equal to M plus N minus 1, then optimal. If it is less than that, degenerate. So how to address degenerate? So among the non-basic cells, what do you mean by non-basic cells? That is unallotted cells whose transportation cost is minimal. Choose that, put epsilon and multiply with the condition that as epsilon tends to 0. So what do you mean by that? Always we can find optimal solution, the transportation problem, even though it is degenerate, because we choose one more cell in order to make, when you are going for optimality, that is addressed. So that is a mathematical result. Definitely those who used Taha book might have seen that result also. See that that is how, therefore it is always possible to find out optimal solution even though initially it is degenerate. So answer is true. So the next is, in a transportation problem, a dummy source given a 0 cost, while in assignment problem a dummy source is given a very high cost. Okay, today we solved assignment problem with a dummy column. What is the cost be given? 0. So obviously it is not high cost, it should be 0, minimal value only, because all the values are cost. Obviously this cannot be minus values, negative values cannot take, so positive non-negative values, so 0 is the only thing. So answer is supposed to be B. So it is not the other way. Many of you said 80, it's supposed to be the other way. So false is the right answer. Right? The solution found by stepping stone or Modi method always preferred over that found by Vogel's approximation. Is it true? Okay, somebody said that way. Is if you have done the course, normally what we used to advise is, please use Vogel's approximation. 99% it gives the optimal solution. Therefore, no need of going for any stepping stone or modified method. That is to validate our answer is optimal or not. For that only we use stepping stone or modified method. So the answer is supposed to be the false. People written that way. It's good. Okay, so today's thing. The Hungarian method operates on the principle of matrix reduction, whereby the cost table is reduced to set of opportunity costs. So while talking, I said this is from the opportunity cost only we are talking about, reduced to set of opportunity cost. That much can be reduced, therefore we are talking about that way. So it is true. That is the first one, is the right one. In a transportation problem, we must take number of dash and dash equal. Okay, there are two things are coming up. How did I start the very first problem? Also similar, am I right? Always when you want to address a transportation problem, unit supplied supposed to be equal to unit demanded. So destination and source need not be equal. In such case, m by n. Columns or rows is nothing but destination and source only. Positive cost coefficients, negative cost coefficients, which is not possible. Warehouse and supplies, see this 1, 2, 3, all are same. Destination, source, columns and rows, warehouse and suppliers, all are same. But when you say this is unit supplied and unit demanded, that is the right answer. So people put, so glad people are aware and other things, right? So now, are used to balance an assignment or a transportation problem. Is it not the same question? So what ways it can be asked? So now, okay, balance an assignment and a transportation problem. Okay, what do you mean by balance an assignment or a transportation problem? Please understand, balance need not be square in this case. Unit supplied equal to unit demanded. The sum of the units equal to sum of units demanded. So the same question in a different way when we ask, there are people are still dummy rows and dummy columns put. It should be unit supplied and unit demanded. So you should know what is the meaning of it. Okay. The procedure used to solve assignment problem wherein one reduced the original assignment cost to a table of opportunity cost is called. So stepping stone method, matrix reduction, Modi method, northwest reduction, simplex reduction. So which is correct? Stepping stone method. Okay, what I said, when you reduce the row reduction, column reduction, all those things are happening in the matrix reduction. So unfortunately, no one chose in the matrix reduction. So it is matrix reduction, not the other things. Method of finding an initial solution based upon opportunity cost is called as Johansson's theorem. Have you studied any time? So opportunity cost is you are subtracting two values to find the ranking in the Vogel's approximation. Therefore, Vogel's approximation is the right one, not the other things. Have you come across this Johansson's theorem as well as Flett's technique? Very good. If you've not seen it, but some method name is given, people will get confused. Therefore, it has been given. Right. Assignment problem can be viewed as a special case of transportation problem in which capacity of each source is and the demand at destination is. So infinity, what is that? If it is infinity, we cannot solve at all because the constraint never met. So we cannot have that part, but it is possible. What is possible? I said supply and demand supposed to be taken 1-1. Why we have to take? Assignment problem is always n jobs are there, n candidates are available. Every job supposed to be assigned to one and only person, and every person should get only one job, not more than that. Therefore, 1,1 is the answer. So 0,0 is not possible. That is no need of talking about the other choices. Okay. Dash occurs when the number of occupied squares, that is cells, occupied squares in the number of rows plus number of columns minus 1. Dash occurs when number of occupied squares is less than number of rows plus number of columns minus 1. Okay, so this is what we are talking about. Degeneracy. It is not infeasibility, not unbounded, unbalanced. It is degeneracy. What do you mean by degeneracy? I said how to solve degeneracy also. Number of occupied cells. If it is an m by n matrix, m plus n minus 1. So when it is less than m plus m minus 1, then it is called as degeneracy solution, degenerate solution, not infeasibility. What is infeasibility? If you go back to the graphical method, what do you mean by feasible region? When the set of constraints satisfied and it is a closed and closed region, if you get, we call it as convex region and all those things, some other reasons. Okay, it is a single region when we get, that is the time we say feasible region. So when a solution, when a basic solution satisfies the set of constraints, that is called as feasibility. So degeneracy is the answer, not anything else. Infeasibility in the sense, even one constraint is not satisfied with the identified solution, then we call it as infeasibility. So unboundedness is known to you, unbalanced is also known to you. Redundancy is a linear combination of same constraint can be a scalar multiple of other. So that is also redundancy. We can avoid that, but here it is not required. Okay. Both transportation assignment problems are members of category LP problem called as linear programming problem called as shipping problem, logistics problem, generalized flow problem, routing problems, network flow problems. If you look at this, today's session, I start about this only. This all comes under network problems, flow problems only. The moment I say network problems, I talked about TSP. Other problem, what you study in graph theory is single source shortest path problem, Dijkstra's algorithm. What is that LPP, corresponding LPP, you can identify it. That is a nice way of learning both. So that is important, right? So flow problem, routing problem. What is routing problem? Is this is also called as capacited vehicle routing problem. The vehicle routing problem is even today most research is happening. Vehicle routing problem, VRP. Capacited vehicle routing problem is a nice problem, I can say in a simplest way. There is one place source, there are n customers waiting. We have to, from that source to n customer, we have to supply some commodity. You have vehicles which is same capacity. Then you have to send to all the people with minimal distance or minimal time. Today, what is happening is this problem is more studied and studying also. People are marrying with machine learning and capacited vehicle routing problem. You can see 2019, there are 7 papers have come, topmost researchers from the world. So you have to look at this. Every problem is mentioned here. It's a potential research problem. Shipping problem is again container loading problems. Logistic problem is a huge area. Logistic is a specialized program in MBA. So that much what one can think of. It's a part of OR and how it has been done. SCM, supply chain management, is another area extension of this. Which method usually give a good solution to the assignment problem? Northwest corner rule. So assignment problem, which method is going to give? So we are not going to use any of this method. What are the drawbacks of using Northwest corner Vogel's approximation method is it can take any fractional values between 0 and 1, but assignment is asking you, demands you to give only Xij can assume 0 or 1. Therefore, I cannot apply. Therefore, this is supposed to be none of the above. In applying Vogel's approximation method to profit maximization, problem row and column penalties are determined by. So, finding the largest unit cost, how you get the penalty in the Vogel's approximation method. So, instead of minimization problem, it's a maximization problem. What you have to do is find the difference between two highest units. Then first highest and second highest, that happens to be here in the last option, that is E. So that is the maximization problem. We do that, then apply usual way. So that is known. Okay. This you have to work a simple little bit. So I'll relax for a while. You have to answer this. What kind of solution it has? So far we discussed, so obviously you should think it of 40, 40, 30, 30, 30, 30. Yes, this side it is okay. Degenerate. Why it is degenerate? ABC 3 plus 3, 6, 6 minus 1. 5 cells supposed to be occupied. We have 40 is one occupied cell, 2, 3, 4. So we have 4. Therefore, it is degenerate, not the other anything else. So all the above infeasible, so that is not possible. Okay. What is wrong with this table? So we have 80, 20, 120. Okay, this is a not pole EV. You can do answer it in the chat window. 80 and 20, 120, 40, 30. Okay, then 60. Okay. Any time? So now look at whether it satisfies the constraints. What do you mean the constraints? 80 plus 20 should be 100. It is 100. 120 plus 40 plus 30, 160, 190. So this is supposed to be less than or equal to. So obviously we have more 80 to 80. So this side 120 is met. This is met. So now you have to think over it before answering it. What are the constraints of this? So the supply is this much. I can supply maximum of 100 units. I can supply maximum of 150 units. How many units has been supplied? 120 plus 40 plus 70. So that is 160, 190. We cannot supply. Therefore, it is not satisfying the constraint. Hence, it is infeasible solution. So it is infeasible solution C. This is what is the optimal solution? Okay, this you have to solve by LPP. I'll give the answer here. This is the optimal solution. Please note down this problem. You need this one for answering the next question. So 80, 20, 100, 150, 250 satisfied. How to find the solution? 80 into 8. Thus 80 into 8 plus 20 into 0, 120 into 6, 30 into 4, 160 into 170 into 6, 80 into 0. You sum up, you will get some value. That is the optimal solution. This is how do you know this is an optimal solution? Is you have to do simplex method, then you'll get a solution. I just put this as needed for me, therefore I put this table. Then that is used directly. I given the optimal solution. Now I'm asked, this solution is obtained by Vogel's approximation. Now identify the solution. What is the solution you're going to get? 100 into 0 plus 120 into 6 plus 30 into 4, so 170 into 6 plus 80 into 9. You'll get some value. Previous problem we got value. The difference between these two solutions is asked. The answer is supposed to be 80. So the answer is supposed to be 80. So when two tables are given, optimal solution and Vogel's approximation, then you can identify what is the difference between these two. So this what I have for you. So what is important in CSIR examination, as per my understanding after seeing some 6 or 7 questions, only 2 areas they are concentrating it. One is on LPP with graphical methods. Sometimes they are talking about queuing theory models only. Queuing theory also they are talking about single server queue models. That's what maximum they are doing it. These 2 parts are suppose since this is another extension, so I talked about that. If you are interested, it can be discussed. Entire optimization techniques can be defined and discussed. So, but time may not permit that much. However, interested candidates can talk and discuss this part. That is possible. So, I'm open for questions. Any questions are there? We can talk. Any questions?
Sir, in chat box, no questions, sir.
Chat box, no questions. Okay.
No questions, sir.
Okay. All right. Okay. Yeah. So then I thank the participants and the organizers for giving me to revisit the subject which I love more. Somehow I got fascinated towards this course. I did 2 courses on this one during my BSc. So after that, I did not get much opportunity to learn, but by teaching this course many years, we become better and better. That's the thing. So any questions, you can reach the organizer, the intern, they'll send it. As I told very clearly, within maximum of 3 days time, you will get the reply from my end. Even if you put organizer takes a day, maximum of 4 to 5 days, you will get the reply. If that related to this course, you can ask any questions. You can send by mail also. You can reach me by mail. My mail also there through organizer. My mail is very simple, prof.kavenkatesh@gmail.com. Okay, that will be put by Tripal. You can just put the my mail in the chat window. Or that would be better for the participants. If they want to reach out, they can reach out. Prof. PROF dot KA Venkatesh, one word. Shall I type it so that you can put it that way? So. This is my mail ID. You can pass it to others. Rashikar, that's the end, right?
Sir? Okay, sir. Thank you, sir. Mail ID I posted in chat box, sir.
Okay, that's fine. Yeah, that's
Okay,
fine.
okay, okay.
All right. Thank you so much.
Okay, sir.
Thank you, sir. We wish to express our gratitude to our resource person for being with us on this event. Your presence and gentle words are a source of encouragement for all of us. I would like to thank Professor Venkatramanan, Head PG and Research Department of Mathematics, for organizing this C4 workshop. Our next C4 session will be held on tomorrow at 11 a.m.